we'll write equations of sinusoidal functions, which are equations that oscillate up and down. Cool. All right, so we are graphing sine and cosine today, so you don't have to write all these words. Example 1. Graph y equals the sine of x. That's all you need to write down. So we're going to graph y equals the sine of x where x is between 0 and 2 pi. Well, that's 2 pi on our unit circle. 0 radians all the way around our unit circle to 2 pi radians. So that's what we're going to do. One rotation of our unit circle. And we're going to see what that looks like. And so this is a little sketch of our unit circle, and this is where we're going to put our graph, y equals the sine of x. And if I wanted to, I could make a little sine xy chart. Sine of x equals our y output. All right, so I'm going to start with 0. When x is 0 radians, we're right here at this ordered pair. What is that ordered pair? 1, 0. Good. So then, what is the sine ratio at 0 radians? 0, yeah. So it's that sine is the y coordinate. So at 0, we have an output of 0.
Whoa.
Okay. And then I'm going to move a little ways away right here. What radian measure is that?
0.
Well, that's the ordered pair, 0, 1. What's the pi over 2? Okay, so pi over 2, which I'm going to call right here, pi over 2. At pi over 2, what is the sine ratio at pi over 2?
1.
1. So 1. So at pi over 2, we have an output of 1.
Oh. We did pi over 2.
Yep. Because my x-axis goes from 0 to 2 pi. So that's moving around our unit circle. All right? All right, so traveling further around my unit circle, I'm right here. What x value, what radian measure is that?
Pi.
Pi, okay. At pi radians, what is the sign at pi?
Negative. Oh, it'd be 0 still.
Yeah, negative 1, 0. It's 0. Very good. The sign ratio 0. So at pi, we are back to 0. And then, bless you. Oh my goodness. All right. Down here we are at 3 pi over 2. At 3 pi over 2, what is the sign ratio at 3 pi over 2?
Negative 1.
Okay, so 0, negative 1 is the ordered pair. The sign ratio is the y coordinate, so negative 1. So at 3 pi's over 2, we're at the value negative 1. And then as we travel all the way around the unit circle at 2 pi radians, what is the sign value at 2 pi radians?
1.
Back to 0.
Bless you.
So at 2 pi, we're back to 0. So let me ask you a question. Theoretically, could I keep going around the circle? Okay. And so if I went around the circle, it would keep that pattern. Yes, it would. And this, ladies and gentlemen, is one rotation of our unit circle. This, ladies and gentlemen, is y equals the sine of x. And this is your very, very most basic sine curve. This represents one period of the sine function. One period means that at this point, you can see we have, it would keep repeating the same pattern as you said. And so one period is the time that it takes for it to do one complete cycle. And then if you went beyond that, it would just be a repeat. Okay? So we have one period here, and the period for this standard sine function is 2 pi. All right? After 2 pi units, that function will just repeat itself over and over. And it goes in both directions, so it could go backwards like this as well. You can graph it on your calculators. So on your calculators, you can always graph that sine curve. You do need to be in radian mode, absolutely. So make sure that you're in radian mode. Radian mode. You're in radian mode, yeah.
Oh, cool.
And then you can type in sine of x. And you want to do zoom trig. Zoom trig. Zoom trig is a good window for graphing trig equations and trig functions. And so there's your sine curve. What? Sine of x. Sine of x.
Where do we go?
Okay. Zoom trig. Zoom trig. Press the zoom button and find zoom trig.
Oh.
All right. So there's your trig function. Did you get it? Yeah. Okay, good. All right. So all of you, if you're not seeing that graph, let me know because you need to make sure you got it right. Okay. What did you get? Did you do zoom trig? Oh. Zoom trig. Okay. So let me tell you a little bit more about this function. Domain. How far left and how far right does this function go? Forever. Negative infinity to positive infinity. What's the range of this function?
Positive 1, negative 1.
Almost. -1 to +1.
Oh, yeah.
Low to high, always, always. We have to have mathematically order matters, so the smaller number should always be to the left. No. True. That's for our purpose here, but in this one goes on forever, right? To the left and to the right. So yes, you're right. Here we just wanted to graph from between 0 and 2 pi, but theoretically, we could go multiple times around that circle. We could also go in reverse around the circle as well to get lots of curves. So I lovingly call this the sine curve. And so that we all remember and have a way to describe this curve, we're all going to sing the sine song. The sine song is middle, high, middle, low, middle. Okay? It's really complicated. Ready? What's the sine song? Middle, high, middle, low, middle. Okay? That was really good. Okay. That was really, really good. So now not only can we have the sine function, which, ladies and gentlemen, what's the sine song? Middle, high, middle, low, middle. Okay. So not only can we have the regular sine song, but could we make this a negative sine function? Yeah. Mm-hmm. And what would the song be if
Middle, low, middle, high, middle.
Okay, so middle, low, middle, high, middle. Okay, so do you see here the tone there? Low for low, high for high. Okay. All right. So very good. This function can be flipped upside down if we put a negative in front. And you can see that it'll still start middle, low, middle, high, middle for that 0 to 2 pi. Okay? So that negative causes a reflection, just like we've seen before. But this is the sine song that we want to know. Middle, high, middle, low, middle. Okay, let's move on.
Okay, bye, son.
All right. We're going to graph example 2. Example 2, graph y equals cosine of x.
Okay.
So isn't it just the same? No. So I'm going to do a little XY chart again, but it is very similar. So again, we're doing one rotation of our unit circle. So I'm going to start here at 0. What is the cosine at 0 radians? 1.
Oh.
What's the ordered pair? 1, 0. And remember, this first ordered pair is the cosine value. And so we have 0, 1 for our first point. So this one actually starts up high. All right.
Bless you.
All right, here at pi over 2. At pi over 2, what is the cosine at pi over 2? 0. Very good. So at pi over 2, we're at 0. At pi radians, what is the cosine of pi? -1. So at pi, we're at -1.
I wonder what this next one's.
At 3 pi over 2, what is the cosine value at 3 pi over 2? 0. And then back to 2 pi, what would the cosine value be at 2 pi?
1.
Okay. And so this is our cosine curve. And I bet you guys are so smart.
I wonder what
the cosine song is. Okay.
High, middle, low, middle, high.
Very good. You guys, brilliant. Geniuses, all of you. Okay. High, middle, low, middle, high. All right. So first of all, be careful. Be careful. It's not a V. Okay. It curves back down. All right. And you need to indicate that it is returning and does not extend upwards like that. So watch those arrows and make sure that your curves are nice and smooth. They should be super pretty. And if I walk around and see all your curves are V's, I'm going to have a problem with it because they are not V's. That is a different function. Okay.
That's the V.
Nice and curvy. All right. And let's see. Again, a period is the time that it takes for it to repeat itself. So this is 1 period of the cosine curve. And you can see that this is where the high value then repeats itself and starts another period. That would be the second period. So again, this period happens in the length of from 0 to 2 pi, which is 2 pi. What's the domain of the cosine curve? The one that goes on forever. Good. And what's the range? -1 to 1. Very good. And again, the cosine song is high, middle, low, middle, high. And these are the 2 songs that you need to know and we're going to work on today. Okay, so we have the sine song and the cosine song. And then we can move these graphs around with some basic transformations. So, I don't want to do that. Let's not do that. Do I want to do it? Don't write this down. We're not going to write it down. Don't write this down. Okay. You can write down these equations, but that's all. Okay. So these are the basic functions that, this is the basic function that we're working with today and tomorrow. Today, our B value is equal to 1. So it's just sine of x and cosine of x. We are going to be modifying the A and the D. And so what we're going to do in your calculators, okay.
What's jamming to that?
All right. In your calculators, would you please put y equals sine of x into y1? Y equals sine of x into y1. And before you graph anything, I want you to predict what it's going to look like. So what does sine of x look like?
Middle,
high, middle, low, middle. Okay. So, what do you think? What do you think this -2 is going to do to that sine curve?
Transfer it. Like, I feel like this is a trick question.
Okay. What do you think the 3 is going to do?
Also transfer it in a different way.
It's going to translate somewhere else.
Huh. Interesting. All right, let's see. So you had a second to think about what it might do. I heard one right answer for one part. So, all right.
I said
So
movement. So
go ahead and type in 3 sine of x minus 2. Make sure that your parentheses. Okay. Parentheses.
whoa.
So there is the sine of x curve. Oh.
Hold on, I got that.
Oh. It's a lot bigger, huh?
It's valleys.
Its valleys are deeper.
Looks like a bunch of fanny packs.
Interesting. So let me change one thing. Let me get rid of this 3 in front first. And so what does the minus 2 do?
Drop.
It shifts it down 2 units. That 2 is on the outside of the sine function. So it shifts it down 2 units. Okay.
A bunch of waves.
Sorry, that looks
All right. Very cool, right? And then, so this is what we would call a vertical shift. All right, that number on the outside is the vertical shift. And then, so what does the 3 do?
It makes it
Okay.
It makes it taller.
It makes it taller. That's exactly what it does. The 3 is a vertical stretch. Vertical stretch or shrink. It's stretching our graph. It's also called amplitude. And so it's making the sine curve, it doesn't just go from -1 to 1 anymore. It's 3 times larger. Okay, so it's multiplying the function by 3. All right, so they have some special names. So this number on the outside is a vertical shift, so we can sometimes refer to it as the vertical shift. Or I often refer to it as the midline or middle, okay? So that's part of our song, middle, high, middle, low, middle. So I call it the midline, okay? And once we plot the midline from there, then this number in front, the absolute value of A is what we call the amplitude. This is important. A is the absolute value of A is the amplitude. You should write that down. And D is the vertical shift or midline. Okay, those are a couple more things that you write. Amplitude is very specific to sine and cosine functions, secant and cosecant as well, but sine and cosine mainly. Amplitude is the distance between the midline and the highest point. And when we talk about distances are always positive. And so we refer to amplitude as a positive value. And it's the distance between the midline and the highest point on our graph. So that's always a positive number. But that amplitude represents, like, this one is 3 units above the midline is our highest point. And also 3 units below the midline would be our lowest point. Okay? So what we're going to do is we're going to graph the midline and then use the amplitude to find our maximum and minimum values on our graph, okay? And so when I graph the midline, a lot of the times I'm going to use a dotted line, depending on where it is. You do not have to write all these words. Example 3, you're going to graph the function. That's what you need to write down. You're going to graph the way I tell you to.
Already.
Okay? So whatever I model, that's what you do. You don't do anything else.
Okay.
You don't plug it into your calculator and sketch what you see on the screen, because that's not what I want. All right? So this is a dictatorship, and you're going to do as I say.
Deal.
Okay? Okay. All right. Are you ready? Okay. So here we go.
There's no way. This
Y equals 2 times the sine of x. So what's the D value?
Zero.
0. Okay. 0. Nothing there, so it's 0. So what I'm going to do is always start by graphing my vertical axis, and my midline is at 0. So I'm just going to go ahead and just do a dotted line. That happens to be the x-axis in this case, but that's my midline. I'm just always going to use a dotted line. Then, I should write that down. I'm sorry. Midline is 0. What's the amplitude?
2.
2. The absolute value of whatever the number in front is 2. That means that I'm going to go 2 units above, which gives me my maximum value of
2.
2. And I'm going to go 2 units below, which gives me my minimum value of
Negative 2.
Good, you're halfway there. Now, because this is a regular sine curve, that regular sine curve starts at 0 and it ends at 2 pi. It starts at 0 and it ends at 2 pi. And that's going to change tomorrow, so we're going to write it down today. It's going to start at 0 and end at 2 pi on the horizontal axis here. And you're going to do that. You're going to put the first one and the last one down. Then we're going to find the midpoint. What is halfway between 0 and 2 pi? What's halfway between 0 and pi? Pi over 2. What's halfway between 1 pi and 2 pi? 3 pi over 2. And I just want to point out that we're adding and dividing by 2. Okay? Because that's going to change tomorrow. Okay? All right. Now you've got all your labels. These are all the labels that you need. And now you get to graph your sine song. What's the sine song? Middle, high, middle, low, middle. So starting at 0, middle, midline. Then you move over to the high, back to the middle, then the low, and back to the middle. Middle, high, middle, low, middle. And every single time, you will have a perfect curve. That's it.
It's for cosine.
Okay? It'll look great every time if you do it my way. If you don't do it my way, I don't know.
Uh-oh.
All right. Ladies and gentlemen, on letter B, what's the midline? 0. The midline is 0. What's the amplitude? 9. Positive. Amplitude is always a positive value. What is this negative doing to our cosine curve?
Starting it off negative.
Reflecting it. It is a reflection. All right. This is a flipped cosine curve. All right. So we're going to start with our midline, which the middle is 0. I'm just going to make that a nice little dotted line there. Our amplitude is 9. That means 9 units above the midline would be our maximum value. What's our maximum value?
9.
And 9 units below our midline would be our minimum value. What's our minimum value?
Negative.
Are they always going to be the same?
Yes.
No.
No, because
You'll see
math
on
is
the next
weird.
one. Yes, very good. All right. So this is our cosine curve. Cosine normally begins at 0 and ends at 2 pi. Then we're going to cut the halfway point. It's halfway between 0 and 2 pi. Half again. What's halfway between 0 and pi? Pi over 2. And what's halfway between 1 pi and 2 pi? 3 pi over 2, adding and dividing by 2 every single time. And now we get to sing our cosine song that's been reflected. So think for a minute. What's the cosine song normally? High, middle, low, middle, high. What's the reflected cosine song? Low, middle, high, middle, low. All right. So at our starting point here at 0, we're going to go to our low value, our minimum. Low, middle, high, middle, low. And just so you know, I didn't make up this song.
Really?
It came from a Sesame Street album.
Yeah,
Plagiarism.
that explains everything.
It does, doesn't it? Literally, like when I was 4, I used to dance around the living room to my Sesame Street vinyl. Yes, we had a record player. I got my big, oh my God. So, and one of the songs was literally low, middle, high, high, low, high, low, middle, high, high, low, middle, high, high, low, high, high, middle, high, low, low, low. It's so funny.
Sesame Street was
Sesame
teaching
Street.
kids about sine and cosine
Oh,
graphing.
yeah, it was. Okay. We're just
Alright.
going to do this last one right here. Let us see. Y equals -2 sine of x plus 1. Y equals -2 sine of x plus 1. What is our midline? 1. What is our amplitude? Ooh, 2. Amplitude is always positive. This is the A value. The A value is -2. The A value can be positive or negative, but when I ask for amplitude, amplitude is always positive. Okay. So on my vertical axis here, my midline is 1. So I'm going to go ahead and make that my midline, my dotted midline. The amplitude says 2 above.
3.
What's my maximum?
3.
3. And then 2 units below 1, my minimum value would be -1. And so this is how it's working. 1 minus 2 and 1 plus 2 gets us our maximum and minimum values. 2 above and 2 below. Okay? The sine curve normally begins at 0 and ends at 2 pi. What's halfway between 0 and 2 pi? Pi. Halfway between 0 and pi? Pi over 2. Halfway between 1 pi and 2 pi? 3 pi over 2. And now we get to sing the reflected sine curve. What's the reflected sine curve?
Middle, low, middle, high, middle.
High, middle. Good. Middle, low, middle, high, middle. And there is our beautiful sine curve. Every single time you plot the points, you connect the dots. You've been trained to do connect the dots since about 5 years old. Right?
Yeah.
If you don't do the dots, it's going to look messed up. I promise. Okay? Connect the dots in a nice smooth curve. Okay? Do you have questions for me?
Why is this guy?